This question is from physics chapter capacitor. Here in the question it is given that three capacitors having capacitance 20 microfarad, 30 microfarad and 40 microfarads are connected in series with 12-volt battery. Find the charge on each of the capacitors. This is the first part of the question. In the second part, how much work has been done by the battery in charging the capacitor? So let's understand this question with a figure. In this figure, we have three capacitors C1, C2 and C3. All are connected in series and here is the battery. Its voltage is given as 12 volt. So we have to find the how much charge is formed on each of the capacitor. This is the first part of the question and the second part is that how much work is done by this battery in charging these capacitors. So first we write the given values. So here it is given that first capacitor C1, its magnitude is 20 microfarad. C2 is equal to 30 microfarad and C3 is equal to 40 microfarad. And here voltage is given as 12 volt. So these are the values given in the question. Now we need to understand one thing. When the arrangement is series arrangement, that time the charge will remain the same. Means whatever the charge is supplied by the voltage, same charge will receive by each and every of the capacitor. But voltage will vary. It means that capacitor C1 will take the voltage of V1, C2 will take the voltage of V2 and C3 will take the voltage of V3. So here we can write it down in series arrangement. Charge, we represent it as Q, is equal to same, but voltage represented as V, it will varies. Now we have to find the value of the charge Q. So to find the value of the charge Q, what we are going to do, we are going to use the formula Q is equal to CV. So total charge we have to find, this one we have to find. But here in the question, total capacitance is not given. Individual capacitance is given, but total capacitance is not given. Voltage we can use as 12 volt, that's the total voltage supplied. So first work is to find the total capacitance. This is our first work. So in the series arrangement, the capacitance formula is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This formula we can use for series arrangement. Now we substitute the value 1 by C is equal to 1 by 20 microfarad plus 1 by 30 microfarad plus 1 by 40 microfarad. Further, 1 by C is equal to, if we take the LCM as 120, so it's equal to 6 plus 4 plus 3 and it's equal to 13 upon 120. So now we can say that capacitance is equal to 120 by 13 microfarad. We got the total capacitance. Now we have to substitute the value in this relation. So here Q is equal to total capacitance is 120 divided by 13 and voltage is 12 volt. So Q is equal to 1440 divided by 13. So now we can say that total charge is 110.76 microcoulomb. So this is the total charge and we know that in the series the charge remains the same. So whatever the total charge we are getting, the same charge is supplied to each and every capacitor. So this is the answer for the first part. In the second part, we have to find how much work is done by the battery. So to finding the work, we can use the formula W is equal to Q into V. This formula we can relate. So total charge just we found and voltage we know. So work done is equal to 110.76 into 12. So W is equal to 1.33 into 10 to the power minus 3 joule. So this is the answer for the second part of the question.